Okay, so part A says state f prime and identify the values for which x does not exist. So that sounds like that might be at least 2 points. It's asking for 2 things. Okay, so your first derivative could look a couple different ways depending on how you did it. If you went the quotient rule route, yours probably looked like where did I write that down? Something like that. I did not go that route, so mine looked a little bit differently. So my suggestion, I always try to avoid quotient rule where I can. So I went ahead and split apart my fraction into 2 pieces, and then I even rewrote this one as an exponent. So then that way I could just do power rule a couple times. Bring the power down, lower the power by 1, bring the power down, lower the power by 1. So whether yours looks like this or looks like this, those are equivalent, so that would be fine. So that's probably worth a point. So the second part is, how do we know for what values of x is the first derivative undefined? So how did you find that? Yeah.
The only places where undefined is that denominator is 0.
So x equals 0. Undefined when you try to divide by 0. Okay, I think that's all there is to part A. Any questions about that piece? Okay, then part B. For what values of x is f decreasing? So how are we supposed to know when it's decreasing? Oh. Somebody else can chime in. When is a function decreasing? Yeah. Okay, so when the first derivative is negative. So again, I don't have the scoring guide here, but my guess would be that you probably get 1 point if you figure out, or if you just set this equal to 0, your derivative, no matter which one you made it look like. If you solve this, hold on, something's off here. Oh, okay. So, yeah, nothing's off. It's just I didn't go far enough here. If I kept solving this, it looks like the first derivative is 0 at plus or minus the square root of -1/4. But taking the square root of a negative number, that's how you get I in your answer. I's are, we call them imaginary. They're not really imaginary, but they don't show up on a graph. So that's not a place where it's increasing or decreasing. So it's not just where the first derivative equals 0, it's also where the first derivative is undefined. So this info from part 1, x equals 0 is still a critical number.
So
was trying to figure out.
So 90% of the time it's when the first derivative is 0, but it's also when it's undefined. That's why I have to say it every time to be mathematically correct. Okay, critical number, the whole point of finding this, again, if you don't know why you're finding this, then you're not going to know to find it when you need to. Critical number is the only place it might be changing direction. So throwing in a number like 1 into the first derivative and seeing that you get a negative means it's decreasing after 0. Throwing a number like -1 in to the first derivative, you still get a negative, so it's decreasing before 0. So I would say probably the most common mistake, if this was a multiple choice question, one answer would be from -infinity to +infinity. And it does look like it's decreasing the whole time, but what's technically not true about this? It's not what? Right, it's not decreasing at 0. So we should say it's decreasing before 0 and after 0.
Let's see.
So something like that. Okay, did anybody get that far on that part? Did y'all know to find critical numbers? And you tested around it? And you got decreasing on both sides? Did you write your answer like that? Okay. Technically, at x equals 0, it's undefined. So it's not really decreasing there. So again, multiple choice, that's pretty common to show. Or to put this as a wrong answer, as a distractor answer. Part C. For what values of the graph is f concave down? Show the work that leads to your answer. Okay, so when is it going to be concave down? Okay. So if that's the piece of information we know, you should write it down. There's always a chance that's worth a point. I think y'all would be surprised that sometimes you get points for stuff like that. Sounds like we need the second derivative. So my first derivative is off the screen, but if I rewrite it, he would look like this. Again, you can use quotient rule again. There's more than one way to make your second derivative look that can still be equivalent. But the way I have it, I can just bring the power down, lower the power by 1. When I bring the power down, this will be a 2. So your second derivative either needs to be 2 over x cubed or something equivalent to it. So you might have to simplify your sum to see if it's the same. So how does this help me know when this is happening? How is this helpful? How does the second derivative help us figure this out? Okay, so point of inflections are when the second derivative is 0 or undefined. So this is supposed to help you see that x equals 0 might be a point of inflection, and the whole point of finding a point of inflection is that's where the concavity might be changing. You don't want to try a million x values, you just want to try a couple. But if you don't know where it could be changing, then you can't just do a couple. So if I plug in 1 into the second derivative, it's positive, concave up. Plug -1 into the second derivative, it's negative, concave down. So the answer to part C should be from -infinity to 0. So certainly a point for the answer. It says show your work. So this counts as showing your work, that number line system, it's not just a good way to organize your thoughts. And my other guess would be that there's probably a point if you got the second derivative correct. But you had to know to find the second derivative, and then you have to know how the second derivative is supposed to help you. Just because you can find a second derivative, if you don't know how to apply it, then you may have gotten 1 point, but you're missing out on a couple others.
Can you set the second derivative equal to 0 and show me how you solve for the point of inflection number?
Multiply both sides by x cubed, you get something that's not true.
Okay, so that's
Second derivative doesn't equal 0, but just like critical numbers, points of inflection can also occur when the second derivative is undefined.
okay.
So where the denominator equals 0 was 0. I just didn't need to write out the steps for that.
That's the part I was wondering about anyways, the undefined part.
Yes, 0 or undefined for critical numbers on the first derivative, and second derivative for points of inflection. Okay, and then part D, does the f of x have a point of inflection? Well, that sounds like a yes or no question. So if you answered nothing on part D, if you ran out of time or something, you should at least flip a coin, because you might get a point by just guessing yes or no correctly. So, well, what is a inflection point? What has to be true for it to be an inflection point? Okay, that's where it's likely to occur, when the second derivative is 0 or undefined. Okay, concavity changes. So it goes from concave up to concave down, or concave down to concave up. Is that what happened at x equals 0? So we think yes. Yes, that's a trick. Well, it's not really a trick, but there's one other thing that has to be true to be an inflection point. It has to be a point, right? Inflection point. X equals 0. How do I know if that exists or not? Plug it into the original function. The original function looks like this. Why can't I plug in 0 to this? All right, it's undefined. Divide by 0. So the concavity changed here. It's just not that it was not a point. It was at an asymptote. So it can't be a point of inflection if it was an asymptote. So I'm sure you'd get 1 point if you just said no. And then, I don't know, what I have written down here is probably not adequate enough of a justification. I'd say something like concavity changes at x equals 0, but x equals 0 is not a point on f of x. I think that would be plenty explanation. So that does come up. I don't just emphasize that just randomly, that you got to be aware of being cautious there. It's easy to say that's yes because the concavity is changing, but if it's not a point, it can't be an inflection point. Okay, so same thing. The main thing out of this, this was not for an accuracy grade or anything, but you guys need to learn from where you got stuck. If there was some things that you didn't know, like how was I supposed to find a critical point? How was I supposed to find an inflection point? How was I supposed to test when it was concave up and concave down? Those type of things, the basics, you have to have those memorized. So please emphasize those in your work.